Okay, so this is topic 4 of rational functions, and so to review, rational function is a function that it's like in rational form, so it looks like a fraction. So there's going to be an x in the numerator and an x in the denominator. So first we're going to take a look at some of the most basic parts of a rational function, which is the domain and range. So for the domain, this should be a review. Very easy. You just look at the denominator. What makes x equal 0? Remember, you can't have anything divided by 0. So obviously, if you have anything that makes that denominator equal 0, that's going to be like not part of the domain. So the domain is technically everything but that value, which makes x equals 0 in the denominator. And the range is a little bit more confusing. It's all the y values. So the y, or the range, is going to be the coefficient of the numerator and the denominators of x. So for example, this is y equals 4x plus 1 over 2x. So you look at the 4x and the 2x because the numbers in front of the x's, and then you don't need the plus 1 at the end, so it would just be 4x over 2x. And then you get rid of the x's, so it would just be 4 over 2. So the range would be 4 divided by 2, so that is equal to 2. So that means the range is everything but 2 in this example. So here's an example from the book that is page 79, number 5. This is page 80, number 3. So this question is, state the values of x for which f of x is undefined. So if this is x, we need to find the domain. So what makes this denominator 2x minus 1 equal 0? So it's just like very simple algebra, move over the 1, so it's 2x equals 1, and then divide by 2, so it's x equals 1/2. So that means that the domain is everything but 1/2. And you write it as that below. The domain is x is like all real numbers except for 1/2. Okay, so now that we've covered the domain and range, we should take a look at inverse functions. So inverse rational functions are the inverse of a function. I think you know what inverses are, but just in case, if you don't, if you multiply an inverse with a regular function, it becomes 1. And basically, an inverse just undoes everything that the function does. So usually for inverse functions, you switch around the y and the x, but if you do that to a rational function, it will be pretty hard to simplify. So an easier way to do it is to literally just flip the numerator and denominator around. So remember, also inverse functions have to be denoted as f to the -1. So just a reminder. And it has to be a function, and so it must satisfy the vertical line test. So draw a vertical line anywhere, and it can't touch more than 1 point. So if it does, if the vertical line you drew touches more than 1 point, that function, or the rational function, does not actually have an inverse, because the inverse, if it's not a function, it just doesn't have an inverse. So again, the inverse is also a reflection of the function in the line y equals x, which is like a diagonal line of slope 1. And it should satisfy this f within f inverse x. Another important thing to remember is that the domain and range are switched around in cases of inverse and regular functions. So in inverse functions, range would be the regular function's domain, and vice versa. So here's an example. This is from page 79, number 5. It is, consider the function f of x equals ax plus 3 over x minus b. And it asks you to find a and b given that y equals f of x has asymptotes with equations x equals -1 and y equals 2. So the easiest one to find first is b, because it's the denominator, and remember that's just like the x values. So you just want to find anything that makes it the denominator, the whole denominator, equal 0. And if the asymptote is -1, x equals -1, that means that if you plug in that for x, so -1 minus b, what what value of b makes x 0? So that would be -1, because -1 minus -1, which is also -1 plus 1, that equals 0. So that is what the value of b is. So now a, remember, it's the coefficients of the x's, both the x's in the numerator and the denominator. You don't disregard anything that doesn't have x in it. So a must be 2 in this case to fit that. So x can be anything. So just pretend you don't know that it's because you don't know what it is. So the coefficient of the denominator in x is obviously 1, because it doesn't have anything else in it, but there is an x. So if the asymptote is 2, that means that ax over x must equal 2. So that means that a must be 2 to make this asymptote of y equal 0. Equals 2, sorry. So part B for this example is consider the function f of x equals ax plus 3 over x minus b. So pretty simple. And then they want you to find or write down the domain and range of the inverse of this function. So this is just very, very easy because it's just the domain and range of the previous function but switched around. There's two ways to find it. You can find the inverse and then find the domain and range, or you could just directly find the domain and range of the previous function or the normal non-inverse function and then switch them around, and both are correct. So if we know that a and b are the asymptotes, well, a is y and then b is x. It's kind of flipped around because b, remember, the denominator is always going to be the x or the domain. So if the asymptote is 2 and the asymptote of y is 2 and the asymptote of x equals -1, so that means that the domain is everything but 2 and the range is everything but -1. But remember, this is the inverse, so the domain should be the range and the range should be the domain in this case. So yeah, that's what I just talked about.